Good morning, students. So, in yesterday's class, we have solved some questions of average speed and average velocity. Okay, but today we are going to solve some questions on instantaneous velocity and acceleration. Okay, and instantaneous displacement also. But before the solving these questions on instantaneous speed and acceleration, we have to know some expressions of differentiation. Okay, these expressions of differentiations are as follows. I am just giving you some very basic and very important differentiation expressions, okay, formulas. And these formulas are, first and most important formula for the differentiation is equals to this one. We have d over dx x to the power n. Okay, d over dx x to the power n. It means we have, in this expression we have x to the power n. Okay, if we change the value of x, then overall expression also changes. And in differentiation also, we will find the change in a physical quantity or the change in a function with respect to change in other physical quantity. If some other physical quantity is going to change, then how it affect the value of other physical quantity. This is called differentiation. Okay, so in this case we have this d over dx x to the power n. It means if we have denominator x, okay, if this denominator x will change, then how it is going to change the value of x to the power n. So this change is given by the differentiation. Okay, and the value of this differentiation and is given by the formula, and this formula is n into x to the power n minus 1. The power of x, which is n, will be in the multiplication term, and the power of x will reduced by 1. Okay, the power of x will be reduced by 1. So now we have dx to the power n over dx, which is equals to n into x to the power n minus 1. Okay, you must remember this formula because this is very important for today's class, and for in further classes also this is very important. Okay, so dx to the power n upon dx is equals to n into x to the power n minus 1. If suppose if you have this 2 in place of n, suppose you have dx square over dx, then there will be n equals to what? N equals to 2. There will be 2 in multiplication and x to the power 2 minus 1. So this will be 2 into x. So this is how you are going to solve this problem. Okay, so this is the formula, first formula. And the second formula we have this one, dk over dx, where k is a constant. Again I am repeating, k is a constant in this condition. So if we have any constant, the differentiation of constant is equals to 0. How it is 0? I am just telling you, differentiation means it is the variation in a physical quantity with respect to other physical quantity, means variation in the value of k with respect to x. But in this case k is constant, it means there is no variation. If there is no variation, then how much variation we can consider? It is 0. So differentiation of x is equals differentiation of k with respect to x is equals to 0. This is our second formula, and this one is third formula. Next, in this next formula, it is third formula. In this you can see k is in the multiplication of x to the power n. It means where we know that this k is constant, but this x to the power n is a variable here. So how you can see, it may happen that value of k is constant, but value of x and x to the power n is changing with respect to time. So differentiation will not be 0. But we also keep in mind that k is constant. So there is no differentiation of k. K will be outside the differentiation term. there is no difference. This will be in multiplication directly, but we have to do differentiation of x to the power n. We have to do differentiation of a variable. So k into dx to the power n divided by dx, which is equals to k x to the power n becomes n into x to the power n minus 1, just like first formula. Okay, so now differentiation of d over dx, k d to the power k x to the power n is equals to k in multiplication as it is, and then we have to do differentiation of x to the power n, which is n into x to the power n. Okay, in first formula also we have solved this expression. And now if we have dx over dx, it means differentiation of x with respect to x. Okay, differentiation of this x with respect to this x equals to 1, means both the x's are same. How you can say variation of x with respect to x itself, how much difference will be there? Same difference will be there, same variation will be there. If x will be changed by two fractions, then upper this x also changes by 2 fractions. That's why 2 by 2 equals to 1. Okay, so this is a differentiation. And this dx means it's very small difference. Okay, and this is very small difference, this is very small difference, it means equals to 1. So differentiation of any physical quantity with respect to same physical quantity will be 1. Okay, then we have this one, d over dx sin x. Suppose if we have sin x in the place of x, in place of any function, d over dx sin x is equals to cos x. Okay, sin x will be converted into the terms of cos x, and then we have d over dx cos x, which is equals to minus sin x. d over dx cos x, differentiation of cos x will be minus sin x, and differentiation of sin x will be plus cos x. Okay, these two terms you have to remember. And the last one is, for our case, d over dx into log x. We have its value is equals to 1 upon x. This is our formulas of a differentiation. But in these two formula of sin x and formula of cos x, these are just opposite to each other. Differentiation of sin x equals to cos x, differentiation of cos x equals to sin x. But in the second case, we have one negative sign. Okay, this is also very important, and these formulas are very, very, very important for our next further classes and for our today's questions. You first read this formula, learn this formula, and then try to solve next coming questions. Okay, today we have 2 questions for you, and 2 questions solved and 2 questions unsolved. Unsolved question, I hope you are doing your best, and just try your best and keep learning. Okay, thank you.